Recall from our last video, we looked at the three basic trigonometric ratios, sine, cosine, and tangent. Well, in this video, we're going to learn the three reciprocal trigonometric identities, cosecant, secant, and cotangent, for a total of 6 trigonometric ratios that you need to memorize. Recall that the side opposite angle theta is called the opposite side, the leg adjacent to angle theta is the adjacent side, and the side opposite to the right angle is the hypotenuse. In our last section, we learned that sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. Remember, you need to start memorizing these ratios. So in today's, we're going to learn 3 additional trig ratios, and they're called the reciprocal identities. First one is cosecant of theta. Cosecant of theta is defined by 1 over sine of theta. Now, I know that sine of theta is opposite over hypotenuse, so cosecant is 1 over opposite over hypotenuse, which means I flip and multiply the bottom fraction. So cosecant of theta is just equal to hypotenuse over opposite. So notice I just flip over the fraction. We do the same thing when we find our secant of theta, which is defined by 1 over cosine of theta. So secant of theta would be equal to hypotenuse divided by adjacent. Cotangent of theta is defined by 1 over tangent of theta. Or in terms of side opposite adjacent hypotenuse, cotangent of theta is equal to adjacent side divided by the opposite side. These are the 6 trigonometric ratios you must memorize. I like to always write my 6 ratios in this order so that it's easy for me to remember which one is related to which. Notice that my sine of theta, its reciprocal is written opposite across from it, so cosecant of theta. Same thing with my cosine, my reciprocal for cosine, which is secant theta, and reciprocal of tangent, which is cotangent. Also notice on the left-hand column, CSC for cosecant of theta is my first reciprocal identity, and now if I go down the bottom, I also get CSE. C for cosecant, S for secant, and C again for cotangent, and that also helps me remember the order of the 6 trigonometric identities. Now let's do an example. For example, when we want to find all 6 trigonometric ratios for angle x. So first thing I got to do is figure out the length of the missing side, or side xz in this example. So I use Pythagorean theorem, and I simplify down. And I find the side xz is 39. So now I'm going to list my 6 trigonometric ratios in order so I know what I need to figure out. Remember my reciprocal identities. So I have sine of x, cosine of x, tangent of x, and then reciprocal identities, cosecant of x, secant of x, and cotangent of x. I know that sine of x is opposite over hypotenuse. So I look at my ratio and I identify which are my opposite, my adjacent, and my hypotenuse side. So in this case, I got 36 over 39. But always simplify the ratio if possible. And yes, I can divide 3 into each of these to get a ratio of 12/13. Cosine is adjacent over hypotenuse, so that's going to get 15 over 39, which also simplifies down to 5 over 13. Tangent, remember, is opposite over adjacent. And so my opposite side is 36, my adjacent side is 15, and that also simplifies down to 12/5. Now once I hit the 3 basic trigonometric ratios, it's easier to get the reciprocals. I just flip them over. Cosecant is equal to 1 over sine, or 13 over 12. Secant is equal to 1 over cosine, which is 13 over 5. And cotangent is 1 over tangent, which is 5 over 12. Notice I just flipped over my answers for sine of x, cosine of x, and tangent of x. Example 2, we're going to solve for the triangle. That means we need to solve for every missing piece. So first thing I'm going to look at is I need to find all my angles. Well, I know 2 of my angles inside, 28 degrees and 90 degrees. Recall that all angles of a triangle add up to equal 180 degrees. So angle A would be equal to 180 degrees minus 90 degrees minus the 28 degrees of the 2 angles I know. That gives up angle A to equal 62 degrees. So now I've found for all the angles of my triangle. Next thing I need to do is find the length of the side. Now always go back to the angle measure given. So since 28 was given, the opposite side of 28 is this AC, and the hypotenuse is AB. I'm going to label opposite as X and hypotenuse as Y. Yourself, which trigonometric ratio involves the opposite side and the adjacent side for a tangent of our angle 28? So that's our tangent. So tangent of 28 degrees is equal to our opposite side of x over our adjacent side of 6. Now I'm going to solve this equation for x. We determine side x is approximately 3.2 inches, rounded to nearest tenths place. So off to the side so I can keep all my answers together, I'm going to write a little answer key. I figured out angle A is equal to 62 degrees, and then side AC is equal to 3.2 inches. And I need to figure out my hypotenuse, or side AB. So that's what we need to do next. There's actually two ways that you can figure out this last side. I can use my trigonometric ratios, or I can use Pythagorean theorem. So let's look at method 1, which is using the Pythagorean theorem. So I know two sides of my triangle. 3.2 squared plus the 6 squared is equal to the missing hypotenuse, y squared. Solving this for y and rounding my final answer to 1 decimal place, I end up with y is approximately 6.8 inches. Method 2, I can use my trigonometric ratio of the side given and the side I want to find. So that would be cosine of the 28 degrees is equal to 6 over y. Solving for y, I end up that y is equal to 6 divided by the cosine of 28 degrees. Punching that into my calculator, I end up with y is approximately 6.8 inches. So now I've solved for all the missing pieces of this right triangle.